Thank you, Mr. Chairman, ladies and gentlemen. Brief, I noticed this. So I take you now to a slightly more abstract plane, but I hope this is also finding some favor in your eyes. Route topology model introduction. I'm also delivering this presentation on behalf of my colleagues in the team, RTM team, Mr. Stefan Brosset and Mr. John Morten Klingheim. We three worked together until very recently to put together the flow of 4 different presentations. So, to the left-hand side you see the topic at hand, routes in the North Sea area. And this is the overview of my presentation. In a nutshell, left-hand side, the trigger event, advent of marine spatial planning. This triggered the RTM work, and of course the intention is to have it for applications in the e-navigation domain, which in turn would provide solutions for the marine spatial planning. So that was the original idea. And in those presentations we will discuss how it is being portrayed, generic versus instance, and existing definitions, what we take on board. We are not alone at home. So let's have a look at this picture, which is taking our region, and this you have seen. And it has been introduced earlier, I don't need to reiterate this, the impact of the marine spatial planning in terms of offshore windmills, as it will most likely look in 2020 plus. Looking into one sea area where we have some legal status already, you see this has been defined in legal terms in Germany for the windmill domain, and what is left of the sea space in the future will be shipping lanes. And they are exactly denoted by coordinates of the corners, and you can retrieve this in some legal documents. So that's the starting point of it, and the statement is marine spatial planning is a fact, let's face it. So how do we do it? Well, and the idea started simply taking, that's a very simple example of course, drawing lines through these shipping lanes, mark them basically, then identify the junctions where they meet, add important nodes, what we call nodes, for instance ports down here. Of course this continues to the Netherlands or to Denmark, northernmost tip and so forth, and then of course finally lift it off. And that's already a very rudimentary route topology model. And that is an abstraction. As you can see, there's not much left of the previous definition, but still it holds true in terms of the traffic relations. And abstract it is. It is composed of very simple elements, namely composed of legs which use nodes. Abstract nodes which need to have an ID, each of those, and of course certain attributes. And of course there are different kinds of nodes. So this is the 2 building blocks. And once we looked into this, what kind of nodes do we have? We identified the junctions. We have waypoints where all the course. Here junctions you have the option to change into an alternative leg. And of course then we have the variety of destinations where you want to go. For instance, ports or offshore sites, anchorages, and there may be others to be determined in the future. It needs to be discriminated between the generic domain and the instance domain. Generic domain means that is something we develop kind of for everybody to use in a global scale, if you will. And that is a contribution to e-navigation. And it was mentioned by Peter already, a common maritime data structure based on IHO S100 framework. And of course this RTM is intended to end up in some way or another in this framework in a generic way. But then we have our topic of the ACCSEAS project, the North Sea region, and therefore we need to, by means of an example, look into that region and come up with a North Sea region route topology model. And of course both the generic and the instance level can be used to build applications. We are not alone at home, so here we are in the middle in this regard. Generic-wise, we look into what has been said internationally in regard to routes. And of course IMO first, Guidelines for Voyage Planning, talks extensively about routes and routing and voyage planning and this kind of stuff. There is a resolution. Then we have, of course, talk in another IMO document about application-specific messages, IMO SN1 Circular 289, where it is explained how you can transmit route information by AAS shore network to vessels and vice versa. Then we have even already how you display routes on an ENC navigational display on board a vessel, for instance, as explained in the latest version of IEC Spec 6/2028. Turning to Europe, we see there is a plan of the past showing some idea of how these routes in the North Sea might look like. I shall come back to this. That's a 10T idea, tying it into trans-European networks. We have already, this was mentioned, another project, Mona Lisa 2, which started standardizing work on the legs and how you exchange this and what attributes are there. This is just a short list. There's a much longer list of attributes developed by there. And last but not least, we have the EU Inspire Directive, and here we have a module which is called Transport Networks, which already builds into this, and I will talk about this later on, and the colleagues as well. So those are our sources, but the idea is also to feed back, and that is one of the tasks with ACCSEAS as well, to feed back appropriately into those fora as is relevant. How has this been constructed in a nutshell? You shall see in the next presentation after the break a more elaborate picture. First of all, we have several sources to take. I introduced this already. This is kind of a static source where the shipping lanes are by legal terms. So we take those into a table of nodes. And then we have the AS footage, which is being analyzed, which I will show later on, or the colleagues will show, and out of which comes those lines, which also go into these tables, and that is a database representing the grid, if you will, the route topology model. Looking into how it's being portrayed, both on the shipboard side and the shore side, we have identified 3 different modes how to portray it. First of all, on an ENC basis, it would look like this. You see the routes indicated somehow. So it's a usual ACCSEAS environment, or in the VTS centers we also use ENC environments. It could be displayed as well. Then of course it could be displayed in a way slightly more abstracted, like you know it from the London tube map or any other city in the world, Paris, take it whatever you like. They all use the same kind of abstraction. Here the topographical connection is deliberately lost in order to show the main features of the grid. And last but not least, and there will be a presentation tomorrow morning by Stefan Prossi on the augmented reality. Now, this picture is where we worked several days for. That is the motorways of the seas level based on our findings, AAS and other inputs, as I introduced earlier. And this is not just an immature sketch or something, but we spent, as I said, several days coming up with decisions on these junctions over here and the lines, and of course took into account the TSS existing, and of course the AS footage. How we did this will be explained in the next presentation. This is from this work we did in the ACCSEAS project, the proposal to have the North Sea region route topology model in the ENC fashion. So it can be zoomed in, and of course each node has a coordinate and it can be retrieved by that. Now this is a sample of how a London tube map may look like. This is the German coast with the motorways of the sea, ports, and the point is, as you can see, it still resembles some geography, but it's reduced to the max in terms of showing the traffic relationships. In a fashion which carries some information, we have additional classes of roads of the sea identified, which would have a different symbol. And here you see the head-up display, augmented reality mode. Here, for instance, it could be introduced the route the vessel is going, and of course it could be introduced if a different route is merging or crossing or something like this. Maybe Stefan comes back to this tomorrow. Well, all these different modes of portrayal or of display can coexist for different applications. This is the architecture mode. The architecture figure, the well-known IMO architecture figure, and here you see the ENC, the London Tube Map head-up display, certainly can coexist for different applications of shipboard tasks, and similarly in a VTS environment, for instance, on the shore side. Last but not least, the idea is that it all taps into the same data model, both in the generic domain as also in the instance domain, so that we really have, within the framework of the common maritime data structure, something which eventually might be called a product or route topology. And of course, it would be ideally the case that we have the same data. So that would be harmonization proper, and that would of course be in the core of e-navigation. And thereby I conclude my introduction and hopefully see you later after the break.
Thank you.